1 over f equals 1 over dO plus 1 over di. So 1 over f equals 1 over dO plus 1 over di. So f is something called focal length. Now I know focal length is something we haven't talked about yet, but it is something we've talked about. It's the length of the focal point. What? Yeah. So focal length is just how far away the focal point is. Okay? So that's focal length. DO is the object distance. And again, that's always measured from the mirror. Oh, in our case, lenses. And DI is the image distance. So it's how far away the image is from the lens. And I will give you this equation. You don't have to memorize it.
Is there an equation to find the image?
Yes. DI is image distance. Image distance. Yes. So this equation is all distances. All distances. Focal distance, object distance, image distance. Yeah. All right, equation for magnification. So this one is M equals negative DI over DO equals HI over HO. So M is magnification. So magnification is a number. It does not have a unit. And it's literally just how much bigger or how much smaller is the image. So if you have a magnification of 1/2, the image is 1/2 the size of the object. If you have a magnification of 10, the image is 10 times bigger than the object is. So the magnification just tells you how much bigger or smaller. DI and DO are the same. HI is image height. And that's measured above or below the principal axis. And HO is object height. Again, measured below, above or below the principal axis. So you can absolutely draw these. Like you can draw lenses. I want to make sure I'm clear on that. The reason we're not is so you don't get confused on the different ways of, like the lenses are slightly different than mirrors. Just like convex and concave are slightly different. I instead of having 4 slightly different things you all have to keep track in your head, I thought it was more reasonable to have 2 slightly different things that you have to keep track in your head. And then these will solve, lenses will solve with the math. Okay, sign of the magnification equation tells you the image orientation and the type of image that is formed. So if you get a positive sign for M, the orientation of the image means it's right side up. And it also means that it's virtual. If you get a negative magnification, it means it's upside down. And the type of image is real. Take a look at this. So when we drew it, notice that the image we drew that was virtual, so the one that was on the right of the mirror, notice how the virtual image was right side up? And notice how the real image was upside down? That's always true. That's always true. So if you're thinking about these, you can always look and be like, hey, my image is upside down. Bam, it's real. Because they're always real if they're upside down. And they're always virtual if they're right side up. Always, always, always. And the reason for this is this negative sign. God bless you. So DI, okay, the image should be on the right side of the lens. I'm doing it from your perspective. Should be on the right side of the lens. The right side of the lens would give you a positive image distance, but it needs to be upside down, so that's where the negative comes in. However, the height tells you the height above or below the principal axis. If it's under the principal axis, it'll be a negative height, and that'll give you a negative magnification. So it works out that way, but that's where that negative comes from. That's why you get that negative there. Okay, what about DI? So if you have a positive DI, it is to the right of the lens, and it's going to be a real image. And if you get a DI that's negative, it's going to be to the left of the lens, and it's going to be virtual. Okay, what's the sign convention for the focal length of the two types of lenses? So the focal length f can either be positive or negative. It is positive for convex lenses. Remember, convex lenses are the ones that look like this. So it's positive for those type of lenses. It's negative for concave lenses. And that's the one that looks like this. Okay? Now, if you're wondering on mirrors, it would be the same thing. This one, concave this time, but the ones that make real images have positive focal lengths. The focal length that's on the wrong side, that's on the opposite side of the mirror, that one's virtual. This would be a negative focal length. Okay, so it works the same way with those. All right, let's do an example. A converging lens has a focal length of 10 meters. Locate the image of an antelope placed 30 meters from the lens. Okay. Yep. Okay, so here's what we know. We know the focal length is 10 meters. It says it's an image upright 30 meters away. Okay, so locate the image that is placed 30 meters away. So that's the object distance. If we put the thing 30 meters away from the lens, then that's a DO. And it wants to know what DI is. So 1 over F equals 1 over DI plus 1 over DO gives me 1 over 10 equals 1 over DI plus 1 over 30. Now, you can totally turn these into decimals if you want, but I would suggest doing what we did when we did circuits. I would suggest common denominators. Here's why. Common denominator between 10 and 30 is 30, so I'm going to multiply the top and bottom by 3. That gives me 3 over 30 equals 1 over DI plus 1 over 30. So I subtract the 1 over 30 from both sides, but I read it correctly. Gives me 2 over 30, which simplifies down to 1 over 15. But I don't want 1 over di, do I? Nope. So what do I do? Yeah, multiply both sides by di, and then multiply both sides by 15. Or, save yourself some time, flip them. Flip everything. 15 equals di. There you go. So that's di. B, find the magnification. Okay, magnification equals negative di over do equals hi over ho. So this confuses people because they're like, well, what do I got 2 equal signs. But ignore the one you don't know anything about. I don't know anything about the heights. Just ignore it. So it's m equals negative di over do. So I'm going to ignore the hi over ho. And it's just going to be m equals negative 15 over do, which was 30. So we get magnification equals negative 1/2. So that means the image is upside down and half the size of the object. Upside down and half the size of the object. Oh, we're going to nail this. Okay, I'm going to keep cruising so we can get her done. Larry the Cable Guy style.
Get her done.
Oh my gosh.
Get her done.
All right. C, find the height of the image if the object is 2 meters tall. Well, I told you that hi over ho could also be part. Well, now I don't need the di-do anymore because I just used that to solve what I needed. I was thinking hi-ho, di-do, it's off to work we go. But di-do, I like that too. That's good. Okay, so I don't need this time. The magnification is negative 1/2 equals hi, which I don't know, over ho, which is 2, because it's 2 meters tall. The object is 2 meters tall, so ho is 2. So multiply 2 to both sides, and you get hi equals negative 1. Yep, told you. I speak truth. All right, last one. Is it virtual or real? There are lots of ways to figure it out. Here's my personal preference. My personal preference is look at the magnification. If the magnification is negative, it is always real. If the magnification is positive, it is always virtual. But there's other ways you can figure it out. Positive di is real. Negative di is virtual. Negative hi is real. Positive hi is virtual. So it's up to you how you figure it out. But that's how you go about doing it.